Hello, my dear students. Very good morning to all of you. Once again, I welcome you all to this TYBSc online lecture. This is the lecture number 4 of chapter number 3, Manufacture of Basic Chemicals. So, let me start the today's lecture. In the today's lecture, the points we are going to discuss, that is manufacture of sulfuric acid by contact process, flow sheet of contact process, and the description of plant and the process. In the last lecture, we discussed the basic principle of manufacture of sulfuric acid. That the basic principle is very simple. Any sulfur material or sulfur raw material or pyrites of sulfurs, those are taken and converted into the sulfur dioxide. Further, the sulfur dioxide is converted into the sulfur trioxide, and the sulfur trioxide, which is absorbed by the water, forms into the sulfuric acid, which is the manufacture of sulfuric acid involves three important steps. Already we studied in the yesterday's lecture. That is step 1, sulfur to sulfur dioxide, step 2, sulfur dioxide to sulfur trioxide, and step 3 is sulfur trioxide to H2SO4. So that we studied in the yesterday's lecture. In this today's lecture, we are going to see the manufacture of sulfuric acid by contact process, as well as the flow sheet for contact process. In the last lecture, we already discussed the two process, that is lead chamber process and the contact process. There are two different methods for manufacture of sulfuric acid. Lead chamber process was there, as well as contact process was there. From that, we compared both the process, and we come to the more favorable process is the contact process. So from that, so today we are going to see the flow sheet of manufacture of sulfuric acid by contact process. So this is the main flow sheet, the main manufacture of sulfuric acid by a contact process. We can see here the flow sheet of the sulfuric acid. Here we can observe very clearly at from the left side end sulfur and the air is there. As already we discussed, the main raw materials are for the manufacture of sulfuric acid is sulfur metals or any material containing sulfur as the element, as well as pyrites of sulfur, that is we can say sulfides, simply it's sulfides, cadmium sulfide, copper sulfide, zinc sulfide, any sulfide materials are taken. And here the burner we can see from the left hand side, initially it was a burner is there, and then that is second is a scrubber, second unit, and third is the drying tower we can see here, fourth is the arsenic purifier, and next is preheater, and after that there was a testing box, and further goes to catalyte, we can say converter, that is sulfuric acid converter is there, and finally there is absorption unit in which the absorption of SO32 by water, it convert into the sulfuric acid, that is nothing but the oleum. Here the flow sheet of sulfuric acid, it divides in a different way. It divides in a different parts. From this picture we can see there are 5 to 6 towers, like we are looking that observation. That is, the first is the dust chamber, second is the scrubber, third is the drying tower, and fourth is the arsenic purifier. And after the arsenic purifier there was a preheater. Before sending the preheater there was a testing box is there. There was a testing box and further converter, and at the end there is a absorption unit is there. Let me discuss one by one of this flow sheet. The plant used in the contact process consists of main 5 parts. That is, first is the burner or the where the raw materials are taken, or pyrites, or we can say sulfur containing material, and second purifying unit, and third testing box, and fourth is the contact converter, already we've seen in the flow sheet, and the last one which is absorption unit. Raw materials, the raw materials are very easy. The raw materials are required for contact process is mainly sulfur or metallic sulfur, iron sulfide such as pyrites, FeS, pyrrhotite, any sulfur containing material, ferrous sulfide, cuprous sulfide, we can say here palladium sulfide, nickel sulfide, zinc sulfide, any sulfide, and can be used, as well as air is very important. Dry air and steam is also used in the process, because air is used for the oxidation. Already we studied in the contact process, air is used as an oxidizing agent. Here sulfur containing material as well as air are the basic raw material for the manufacture of sulfuric acid. Purifying unit, already we discussed, there is 5 important parts we are seeing. Raw material, that is burner. In the burner, all the raw materials are taken and they are heated up to 1000 to 1500 degrees Celsius, like all the raw materials are heated, and further the heated gases are sent toward the purifying unit. Here the purifying unit consisting of different part, that is, one is the dust chamber, second is the scrubber, and third is the, we can say, drying tower, and fourth is the arsenic purifier. Likewise, 4 chambers are situated in which the different purification can be done. As the gases are completely burned in the burner, they passes through the certain pipes. These coming out gases are from the burner contains impurities like dust or some of arsenious oxides, water vapor, some sulfuric acid, fog. They can be removed by the different purifying unit. Here the gases are first passed through the dust chamber, in which steam jets are introduced from the top of the dust particles. With the droplets of water, the dust particles are settled down at the chamber. With this, the dust can be removed. Means continuously tower is there. Here the gases are passed from the tower of the top. The water, the steam jets are introduced. What happens from that steam jets? The complete dust particles, if are present, they can be settled down at the bottom, and then the pure gases can be passed toward the scrubber. Where in the scrubber, the gases are cooled up to the 100 degrees Celsius. Once the gases are cooled and they are passed through the scrubber to remove the acid fog, then these acid fog, once it is removed, these gases are passed through drying tower packed with the pieces of quartz, where the concentrated sulfuric acid flows down and the top of absorb the moisture present in the gaseous. Means where the gases are free from the water, can be we can say here from the free from the water can be it can be done by the drying tower. And then there is one more of purifying unit, that is arsenic purifier. Finally the gases are passed through the arsenic purifier, where the ferric hydroxide removes the arsenic oxides in the gases if it is present. So likewise, there are purifying unit contains 4 chambers. One is the dust chamber, second is the scrubber, and third one is the drying tower, and fourth one is the arsenic purifier. If it is passes through these gases, then finally we get the sulfur as well as sulfur gases as well as oxygen as a pure form into the sulfur dioxide as well as the oxygen. And final, they passes toward the testing box, where this is the testing box in which this is a rectangular box is there, where it is the application of Tyndall box, that is Tyndall effect, in order to show that the gaseous, whether it is free from the dust as well as arsenic oxide, where the initially the sulfur raw materials as well as oxygen is taken, there is formation of sulfur dioxide was there, the formed sulfur dioxide as well as the pure air, in which whether it contains contamination or if any dust particles or arsenic particles if it is present, those can be checked out by this testing box. How it can be work? Very simple. This is application of Tyndall effect. Already we studied in the previous standards. That is, Tyndall effect is nothing but there is the view of a particular gaseous by through a microscope at the perpendicular to the path of the light, where if it is we can see some of the any scattering of light, we can say that the dust particles or solid particles of impurities can be present. If any view in the microscope, we can say there is no any view of the scattering of light, we can say that there is completely absence of the any impurities will be there. So likewise, there is the application of Tyndall effect is there. With this, the testing of the gases can be done here. If the gas particles or in dust particle, if it is present, and then they can be passed over the dust chamber, scrubber, drying tower, and the arsenic purifier. If without any dust particle or any particles, and directly they are sent towards the converter, where before sending the converter there was a preheater was there. Already we seen in the flow sheet there was a preheater, and which in the preheater is nothing but there is approximately before sending the direct converter there are a certain temperature is applied to the gases where the temperature is reached about 300 degrees Celsius. So here in the contact converter, this is very simple. In this contact converter, there is a the main reaction, that is second step reaction, which is carried out sulfur dioxide to sulfur trioxide by atmospheric oxygen in presence of platinized asbestos or vanadium pentoxide as a catalyst at 500 to 600 degrees Celsius, where this reaction takes place in the contact converter. Here, before sending the converter, the gases are passes through preheater where the temperature is rises about 300 degrees Celsius, and before they admitted to the contact converter. As the gases passes through the catalyst pipe, the sulfur dioxide is oxidized to sulfur trioxide since the reaction is exothermic. Exothermic is nothing but there is a heat evolution reaction is there. Once the heat is produced, the temperature itself it is maintained, so that there are two different converters are there in the first conversion at 595 degrees Celsius, where the rate of oxidation of sulfur dioxide to sulfur trioxide is about 80%. In the second oxidation, the gases are cooled and further heat exchange will be there, and subsequently passed into the second converter where the temperature is 450 degree. Here the rate of conversion is 97%. Likewise, the sulfur dioxide conversion into the sulfur trioxide can be done by the two conversion, that is by the two converter. At the first converter there is approximately 80% of yield is there. In the second converter there is 97% of heat will be there. With that, sulfur dioxide is converted into the sulfur trioxide, means there is a formation of sulfur trioxide. Further, this formed sulfur trioxide finally sent toward the absorption tower, where from the top of the absorption tower there will be continuous passing of steam as well as certain sulfuric acid concentrated H2SO4 is passed, where as we know that if you directly pass the sulfur trioxide over water, it forms a acid fog or mist formation is there due to the exothermic reaction. Means there is a dense formation will be it can be done, it can be a dense formation will be there. To avoid the mist formation or dense sulfuric acid fog, this concentrated sulfuric acid is added, which forms oleum. Means with that water, concentrated H2SO4 is also passed over the sulfur trioxide, where the H2SO4 plus SO3 both are can form the oleum, which is nothing but there is a combination of bimolecule of the H2SO4, and further this formed oleum can be diluted with water to form into the desired sulfuric acid. So very important, the role of H2SO4 here, it is very important. To avoid the direct adding the water, we must add the H2SO4 also, that is concentrated H2SO4 also. It forms H2SO4 plus SO3, it forms into the oleum, that is there is the H2SO4, that is dimeric of H2SO4 form, that will be oleum, and further this oleum can be break down into the sulfuric acid. Likewise, there is a simple easy formation of H2SO4 is there. So with this we can say here the manufacture of sulfuric acid by contact process, it is very simple. It has 5 different parts. One is the initially, that is raw materials we are taken, that is burner or pyretes, where all the raw materials are taken, heated at approximately 1000 to 1500 degrees Celsius, and further they are passes through purifying unit in which all the gases are purified and sent towards the converter, where the reaction takes place. SO2, that is sulfur dioxide, to sulfur trioxide in the conversion in the converter with using the catalyst platinized asbestos as well as vanadium pentoxide. And further, the sulfur trioxide, once it is formed and passing towards the absorption tower where the absorption takes place by the water, SO3 plus H2O, it gives to the H2SO4. To avoid the mist formation, to avoid the dents of sulfuric acid, we have to add the sulfuric acid also, concentrated sulfuric acid, by which there is complete formation of oleum, and further this oleum diluted towards the sulfuric acid. From this we can get the desired sulfuric acid. So I hope with this, manufacture of sulfuric acid by contact process is over. You can understand very clearly. So with this I will stop here. In the next lecture we will see the physicochemical properties of sulfuric acid. Okay, thank you so much for watching this.